All right, you guys can turn in your PowerPoint. Hold on a second. Let me share the screen with you. You guys can turn in your PowerPoint to the female reproductive system. Right here, we're going to go over that. We're actually going to be, we'll go through this. Let me check something really quickly here. Let's make sure that we are. Okay, I think we're good. Just want to make sure my voice is on since I had some trouble yesterday. Okay. All right, so you guys can turn. We're going to be in your book on page 541. We're going to read a couple sections of this just so that, you know, I don't confuse you because there's a lot of hormone involvement in this one. A little bit more than the male reproductive system, a little bit more complicated. So let's look first. A few things. One we said yesterday, you know, the primary organ for females is the ovary. It's right over here. Okay, on either side, there's two ovaries, because it's the one that produces gametes. And gametes for female reproductive system are your oocytes, or eggs, or ova, whatever you want to call them. So let's look at the rest of this. There's no ducts in the ovaries like there is in the testes. There's only follicles, and that follicles actually are what the eggs are really develop and mature in. They're kind of like a little house for each ova, has its own follicle, and we'll talk about that in a little bit. Okay, but a few things. First of all, on the anatomy. So the ovaries are here. Okay, this tube right here is the fallopian tube or the uterine tube. Okay, you'll hear it called either or. These little finger-like projections on the end of the fallopian tube are called fimbriae. And they actually have cilia that contain, that actually like brush in eggs whenever they're released. So unlike the male reproductive system, the ovaries are not physically connected to the fimbriae. Anyway, so this is the fallopian tube or the uterine tube, and it enters into the uterus. The uterus is this kind of pear-shaped organ. It's very muscly. We'll talk about it more in detail in a few minutes, but definitely more of a muscular type of organ. These are ligaments that actually kind of attach all of this together that shows right here. Okay, the cervix is this bottom portion of the uterus, kind of a narrowed portion, where cervical means neck, so it's kind of like the neck of the uterus, if you will. And then the vagina or the birth canal is at the lower portion of the female reproductive system. Okay, so we'll talk about that as we go. A few things. Ovaries, like I said, the oocytes are the egg cells. Ovulation is the process of an egg being released from the ovary. This happens once a month, or approximately once a month. And so we're going to talk about that in a little bit too. Let's see. It's released on a mature egg, yeah, about 1 a month. All right, so ducts that are in the female reproductive system. Let's go up to this picture and we'll kind of go through here as we go. Again, the uterine tubes are also called the fallopian tubes. Okay, and there's a few things that are really important about this. Number one is that is where fertilization occurs. So when the sperm enter into the female reproductive tract, okay, they actually travel up through the uterus, and fertilization has to occur inside the fallopian tube. Now, there's only one egg that is released each month, and you don't know which ovary it's coming from. So it could be either one. There's only one a month, not one from each ovary, but one per person, unless, you know, there's something crazy and they have two and then they have twins or something. But so anyways, but that's what occurs. That's where fertilization occurs. Now, what happens is these fallopian tubes work as like a duct system, kind of connect the ovaries to the uterus. And those fimbriae, again, have vibrating cilia on the end of on each of their cells that push or propel that oocyte on into the fallopian tube. And then those cilia continue along with smooth muscle that wraps around the fallopian tube all of that continues to push that egg or that ova on into the uterus. Okay, sometimes, here's one thing that can occur, and you can see how this might happen. Sometimes these fimbriae don't catch the egg, if you will. So egg leaves the ovary, but it doesn't get drawn up into the fallopian tube. And this can mean a couple things. One, it's if fertilization doesn't occur, it's not really a big deal. It just goes wherever. Okay, but if fertilization does occur, so let's say it doesn't get swept up into the fallopian tube, but a sperm makes its way all the way through the ovaries on into the pelvic cavity, because this all will just be like the pelvic cavity out here, and it fertilizes it outside of the fallopian tube. That causes what's called an ectopic pregnancy. Now, this can also happen if implantation, so if a fertilized egg maybe it does get fertilized in the fallopian tube, but it also implants in the fallopian tube. Normally, that fertilized egg, a zygote is what that's called, should implant right inside the uterus, on the wall of the uterus somewhere. Okay? But if that doesn't occur, if fertilization occurs and that zygote implants somewhere outside, maybe it implants on the outside uterine wall or somewhere else in the pelvic cavity, that's an ectopic pregnancy. And you guys may know somebody who's had an ectopic pregnancy before. That happens, but it would cause a miscarriage, before too long. So that is fallopian tubes. Okay, the uterus, the next thing that's listed on here, that is also called the womb. That actually is the place where babies develop. So this is the uterus, and it stretches out. It'll be the size of a watermelon before the baby's born. Okay, so you've got, uterus has 3 layers, kind of like our, blood vessels, heart, lungs, everything else. It's got 3 layers. It has the perimetrium, and that's the outermost layer, kind of an encapsulated type of layer. Then it has the myometrium, and you can guess, myo, remember, is muscle. So the uterus has thick, smooth muscle. And that's because, of course, it has to push a baby out through the birth canal. So it needs to be a very strong muscle. It's smooth because it's involuntary, right? We don't just decide that we want to have contractions and have a baby. That all occurs by hormone. Okay, then the innermost layer is called the endometrium. Makes sense. Inside. So the endometrium is the innermost. Okay, now the endometrium also has 2 layers. It has what we call a basal layer, which is at the base of it, and then it has a functional layer. And the functional layer is the layer that actually, where a baby would be implanted, and that actually sloughs off in the menstrual cycle. Okay, so that is the uterus. Again, it's hollow, very, very muscular. The cervix, again, is this neck portion down here. This is the cervical region, cervix. Okay, and this is the part that thins out and that dilates during childbirth. So when somebody says, oh, they're dilated to an 8, okay, what that means is that the cervix, which normally is pretty well closed at a 0, would be opened 8 centimeters. Okay, 8 centimeters dilated. That's what that means. So that's what they're talking about when they say that. Okay, now the other thing to know about the uterus is that it is anteriorly flexed. So it actually, I will set it out. I have a little model where you can actually see this stuff pretty good back here. I'll leave it out for you guys. And that's that. Okay, the next on our list here is the vagina or the birth canal. Okay, so this is a kind of frontal, what's the word I'm looking for? Plane. There we go. You can see whenever you look at this picture. So a few things you can see on here really well, how the uterus is anteriorly flexed, and then the ovary kind of sits up here above the uterus. Okay, the cervix here, and then the vagina or birth canal is down below that. Okay, the birth canal has very thin walls. Okay, the back of it pretty well lines up with the rectum, and then at the front of it you can see the bladder. Okay, you can also see how whenever this uterus swells up, you know, the size of a watermelon, how it can affect both the rectum, the intestines, and the bladder. It completely swishes the bladder. Okay, external genitalia. The other word that you'll hear for the external genitalia is called the vulva. And they're kind of, all of the external genitalia is called the vulva kind of in general, in reference to all of it. So as far as external genitalia goes, okay, you've got the mons, the pubic symphysis, if you'll remember, that's where the two hip bones meet up, and there is a fibrous tissue right there that becomes really pretty stretchy, or fibrous cartilage becomes pretty stretchy in childbirth so that birth can occur. So that's the pubic symphysis. On top of the pubic symphysis, females have what's called the mons pubis, and this is just a fat pad that's on the front of their pelvic area. Okay, again, the urethra, if you'll notice in this picture, and this picture is in your book too, you'll notice the urethra sits anterior to the vagina. So again, the urinary system and the reproductive system in females is completely separate, okay? The bladder and the urethra sit in front or anterior to the uterus and the birth canal. Okay. Some other things to take note of on here, of course, the urethra, the clitoris. This is actually erectile tissue. It's kind of, in comparison to, like, counterpart, I guess, to male penis, that actually does become engorged in sexual activity as well. It's covered also, it doesn't say that on here, but it's also covered by a prepuce of extra bit of skin. Okay. From there on out, the external features are the labia majora and the labia minora, and these are two fatty areas of skin that actually kind of help to protect the vaginal opening from bacteria. So that's the labia majora. It's actually along the outside. It's a little bit larger. Labia minora is another flap of skin on the inside. From there, okay, what else? Let's see. Oh, the greater vestibular gland is kind of at the back of the vestibule. You'll hear that word. It is what's basically located within the labia minora. Kind of a cavity, if you will, that contains or houses the vaginal opening. And the greater vestibular gland is kind of at the back of that vestibule, at the back of that opening, and it has secretions that help to lubricate during sexual activity, so it helps to do that. Now beyond this, you can see, I think we've talked about everything else here. All right, then we have the mammary glands. Of course, breasts are also external, some of the external anatomy for females, but the mammary glands within that, actually you can turn on over, there's not a picture in their PowerPoint with this, but you can see that picture on 545. Okay, so let's look at that for a minute. So the breast tissue is all in front of the pectoralis major. So that's, your chest muscle. So breasts are basically composed of fatty tissue and mammary glands. Now, when mammary glands are not functioning, they virtually provide they don't take up much space. For the most part, breast development has to do with fatty tissue, as well as, those glands and how dense they are and that kind of thing. Now, a few things to note on here, on this picture, you can, excuse me, you can see anytime you see that word lacto, think milk, okay, like lactose intolerant or lactate or whatever it is, that has to do with milk. So lactation is a process of producing milk. So the lactiferous glands are the ones that produce milk, and then you have the lactiferous ducts that go from the glands to the nipple. They're at the end, and they would produce milk. Now, milk, I had somebody ask me this last year before, women don't produce milk all the time, and even for women who are breastfeeding, that milk doesn't just pour out all the time either. It's all hormone related, and that hormone kicks in immediately after birth. As you get that initial hormone that causes, well, in the beginning you don't actually have milk. You have what's called colostrum. It's like a pre-milk kind of fluid that's really nutritious and good for newborns. And then beyond, after a couple days of that, then the milk will come in, and it's all hormone related. All it takes is to think about the baby or hear them crying. I watched this funny episode one time of The Office. Y'all ever watched that movie? And Dwight is constantly trying to, one of the ladies had been breastfeeding, and he's trying to make her lactate all the time. So he plays all these baby crying and all this stuff, and trying to get her to do that. But that is the truth. It's very psychological, and it's all hormone related. So they hear their baby crying, that can make their milk let down. And so it's pretty crazy how that works. But anyways, so talking about breast tissue, the nipple is the protruding part at the front of the breast tissue, and the areola is that darker pigmented area around it. Now there's lots of lactiferous ducts that leak out or that meet the end of the nipple. There's not just one duct and all the milk comes out of that. It actually, there's several ducts at the end of the nipple where that milk comes out. Prolactin is the name of the hormone that causes that milk production. It said that mammary glands actually function as like modified sweat glands. Kind of interesting. Okay. All right, oogenesis. So oogenesis, like I said, there's like 1 to 2 at birth. Okay, females have 1 to 2 million oocytes at birth. And then at puberty, they usually still have somewhere, wait, that doesn't work. Oh yeah. Oh, I put about 250 to 500,000 are still present at puberty. I mean, I put million. I was like, that doesn't work. And then, but only 1 is released per month. So, you end up with lots of extra. You end up using all of those. Okay, so again, for females, this whole process begins before birth. It's like it starts. So you have all these primary oocytes that begin, okay, before birth, even before birth of that female. And then it just kind of halts, and it stops right there. And they stay as immature oocytes that stay in their immature follicles. And then once puberty begins, they'll start undergoing that next meiotic division. So that occurs, and that occurs whenever they start having ovulation. That process actually occurs. And so a secondary oocyte then is what actually gets moved from the ovary into the female reproductive system, duct system, if you will. Polar bodies. Okay, so when meiosis occurs, if you go back to that picture, you go back to the picture on 530, you can kind of see on here meiosis, how it has like different phases from there and all those daughter cells. Well, polar body is another daughter cell that occurs during like when all these oocytes are being formed, but polar bodies are non-functional. They don't actually do anything. So that's more detailed than what we're going to get into, but just so you know that's on there. All right, let's start looking at the female sexual cycle. So we're going to look at the monthly cycle of the female reproductive system. Okay, so sometimes we hear it as the menstrual cycle. It's usually about 28 days long, but it can be anywhere from 21 to 40. It can be normal for a person. And so the whole purpose of this cycle is to release an egg in preparation for fertilization. So split in, you can kind of look at this 2 ways. We look at the ovary part of it and the uterine part of it. So the ovarian cycle and the uterine cycle. But keep in mind, as we talk about these separately, they actually work together. So while the ovarian cycle is going on, so is the uterine cycle in preparation for the egg and so forth. So think of, this is all occurring at the same time. Okay, the ovarian cycle, when we look at this, I want us to actually kind of read through this. It says, this is a sequence of events. I'm on page 546. Okay, so we're looking at, it's got two basic phases, a follicular phase, like it says on here, and then the luteal phase. So in the follicular phase, it says each month several follicles from each of the two ovaries develop into primary follicles, and then eventually one will kind of emerge as the leader, if you will, and only that one is released, one per month. Okay, it says the maturation of the primordial follicles into one dominant primary follicle marks the initial stage of follicular development. The cells of the primary follicle surrounding the oocyte then divide. Remember, the follicle is kind of that house around each egg cell, each oocyte. It's got its own little follicle, its own little house that it develops in. It says when these cells become more than one layer thick, then they're called granulosa cells. And at this stage, it's considered a secondary follicle. So when those cells around the outside turn into more than one layer. And you guys can actually, there's a good picture too on, well, actually you can use one on the board, I guess. Okay, it says the secondary follicle grows and the oocyte develops a clear extracellular glycoprotein coat called the zona pellucida. Spaces filled with clear liquid begin to appear in the follicle around the oocyte. So let's look at this. So here, right here, okay, we've got all this maturing into that primary oocyte, into the secondary. So this number 3 right here, if you follow along on the picture, it says that number 3 is a late secondary follicle, and number 4 is a vesicular follicle. So here you can see there's still fluid in here, but it's still mixed in, and here you have that good antrum around it. So it's kind of a big blob of fluid, if you will. Okay, so at this point it's a vesicular follicle. There we go. As the follicle develops first into a late secondary follicle and then into a vesicular follicle, the growing number of granulosa cells triggered by FSH secrete greater amounts of estrogen. And follicle stimulating hormone comes from the pituitary gland. So this is all starts in the brain, okay, with the hormones. And so in light of that follicle stimulating hormone from the brain, we have these cells, all these cells around here, okay, these pink cells that are around the outside of this follicle, start producing estrogen. Okay, so these start producing estrogen. Now, kind of look at that next thing. The pictures on 547 shows you different charts of what's going on basically at the same time. Now, what we're considering here is the very beginning of each of these charts is day 1 of like a female's period, menstrual cycle. So day 1 of bleeding starts at the beginning of each of these graphs, if you will. Okay, so first week is what it's considered. You'll notice, well, let me keep going through here and then we'll get to that. So it says this figure C shows the steady rise of estrogen from day 5 to 14. So if you notice in there, okay, that's when you have these follicles are starting to produce estrogen. So that's how that all fits in. Okay, that vesicular follicle is producing estrogen, okay, up until ovulation. All right, now it says the rising estrogen level inhibits release of FSH from the hypothalamus. So as that estrogen rises, it signals back to the brain that it needs to slow down that follicle stimulating hormone. So it's that negative feedback and that we've been talking about all year long. So notice what happens at ovulation. You have the follicle stimulating hormone that's starting to decrease. But anyways, so which is why it says the FSH level decreases slightly from 6 to 12. You can see how it kind of goes down for a little bit. The large vesicular follicle now bulges against the ovarian wall. You can see it in B. I'm sorry, not B. It's actually in this picture on the board. It says it's about this time the pituitary gland starts to secrete more FSH and luteinizing hormone, and the high levels of luteinizing hormone, which also comes from the pituitary gland, causes the oocyte to complete its first division, and the secondary begins its second meiotic division. So it starts that maturing process so that ovulation can occur. Now it says the surge in LH then causes the bulging vesicular follicle to rupture the ovarian wall, and we have ovulation. So that's when ovulation occurs. Ideally, okay, ovulation occurs about day 14 of the menstrual cycle. Now, here's the thing. You can't always assume that ovulation is going to occur right in the middle of the cycle. Okay, it doesn't always occur on day, it doesn't always occur 14 days after the end of the last menstrual cycle. But it should occur 14 days it should ideally come 14 days before the next menstrual cycle. So that's one of the reasons why it's kind of hard to tell when ovulation is really going to occur, because you don't know when the next period is going to be. And ovulation occurs 14 days before that next period. So you can't just go by it always happens on day 14. That it would, but that's only if you had a 28-day cycle every single time. And most people don't, And it's still not guaranteed to happen on a certain day at a certain time. Hormones are different. Okay. Says the result is ovulation, the release of the secondary oocyte and a layer of surrounding cells called the corona radiata into the pelvic cavity. So this little corona radiata has a little bitty house of cells around it, and that is released and hopefully brushed up with the fimbriae into the fallopian tube. Okay, this release concludes the follicular phase of the ovarian cycle. So when ovulation occurs, that follicular phase is over. Okay, so look what happens to luteinizing hormone and follicle stimulating hormone. Notice that they really drop. If you look at that graph A on page 547, both of those hormones drop dramatically when ovulation occurs. Okay, now it says the luteal phase. Okay, it says the oocyte normally will be swept into the uterine tube by the vibrating cilia of the fimbriae. The remaining cells of the follicle, which are still in the ovary, form what's called the corpus luteum. Now, notice luteum, like luteal, luteinizing hormone and luteal phase. Okay, luteinizing hormone, which surges during ovulation, helps stimulate the formation of the corpus luteum. So luteinizing hormone has been doing that all along. Okay, so it's helped form that. The disruption of the estrogen-secreting granulosa cells cause blood estrogen levels to plummet after ovulation. The cells of the corpus luteum begin to secrete what's called progesterone. Now, progesterone is another hormone that's released by the ovaries, okay, because that's actually produced by the corpus luteum in the ovaries. And this says the blood rises steadily through the early part of the luteal phase. The corpus luteum grows. It secretes modest amounts of estrogen that goes from there. But progesterone is kind of the pregnancy hormone. So progesterone, the corpus luteum continues to produce progesterone if fertilization occurs for a little while until the placenta actually starts producing it on its own. So progesterone is kind of your pregnancy hormone, and that's one of the ways in which birth control works. Is birth control kind of tricks your body into making you think that you're pregnant so that you won't continue to ovulate. Because someone who is pregnant will not continue to ovulate, so you can't get pregnant while you're pregnant. Okay, and that's one reason is this luteinizing hormone, is the corpus luteum and that progesterone. After about 10 days, the corpus luteum begins to disintegrate if the oocyte has not been fertilized. So if fertilization didn't occur, because it would have to occur within a few days, within 24, 48 hours of ovulation. And so if that doesn't happen, then that hormone drops, progesterone drops back down, and it turns into what's called the corpus albicans. And in light of that, okay, that's what begins then at that point the menstrual cycle would kind of come back to play. Now let's look at the uterine cycle. Give me just a second. Okay. Hold on. I'm texting it. Schedule something. Okay. So real quick, we'll kind of get through the rest of this. Okay, so the luteal, we were talking about the uterine cycle. Okay, let's look at that. All right, so we have the menstrual phase. Go back over here to 547 on that, and that picture at the bottom there. So we've got 3 phases within the uterine cycle, and this is the same idea as it falls into the same time period as the ovarian. They work together, they overlap, okay, and they're all related. So first you have the menstrual phase. This is usually the first 4 to 5 days of the cycle, and this is when the endometrium, the functional part of the endometrium, actually sheds, and this causes the bleeding that we know of as the menstrual cycle or a female's period. So that's what happens there. So this starts when the first day of basically of period. Okay, the proliferative phase is where the endometrium actually grows back. And this ovulation, so it keeps growing until ovulation occurs. And once ovulation occurs, it actually pauses growth, kind of slows it way down. And at that point, the hormones that are in there actually cause blood vessels, increased blood flow, increased blood vessel development to grow in the endometrium. So instead of growing up tissue-wise, it just becomes very, it matures in such a way that it develops a lot of blood vessels. And then last is the secretory phase of here. Okay, and this is where the endometrium actually is right after ovulation occurs. So it's not growing back anymore. It's ovulation has occurred. And then you've got this time period where all of that blood flow is increased, what I just was saying. All of that blood flow is increased. There's lots of blood vessels. And that's in preparation for an embryo. So an embryo, so a fertilized egg, a zygote, would get implanted into the endometrial wall somewhere. Okay, and once it does that, then it needs all this extra blood flow to get blood to the embryo, nourishment to the embryo, and so forth. So basically, every month, what happens in the menstrual cycle or uterine cycle, whatever you want to call it, is that it prepares constantly for pregnancy. So the uterus, every month, it just gets ready for a new zygote, and it gets ready every month for a baby. I mean, that's the purpose of it. That's what's going on. So, okay, that is that. Now, if fertilization doesn't occur, then during that time period, then progesterone falls down, and that's what causes that sloughing of the endometrium, that functional layer of the endometrium. Start back over. All right, last slide on here is the female sexual response. So a couple things to know. You can flip on over to page 549. It's that last little section talks about this. Female sexual response, stimulation occurs similarly to male. Tactile or psychological arousal occurs. And much like an erection for males, the clitoris becomes erect for females during sexual arousal, and that increases secretions from the vestibular gland and the vaginal wall. That just aids in, it facilitates sexual intercourse. And one thing that's different females to males is females, orgasm is not required for females in order for conception to occur. Versus males, it is required because that's what causes ejaculation. Okay, so that is that. That's anatomy. Again, Monday, y'all are going to be able to work on your chapter packet. Tuesday, we're going to talk about fertilization, pregnancy, and childbirth. Fun times. So anyways, that is that.